We're now going to look at integrating circular functions. For this course, we only deal with sine and cosine. We don't look at tan or secant, and it really is just a reversal of the differentiation process that we considered in a few videos ago. So it's reasonably straightforward. All right, so if we recall that when we differentiated sine of some function, kx plus a, where k and a are constants, then the derivative of that was k cos kx plus a. Okay, so if we're going to do this in reverse, we just need to take the reciprocal of the k. So we're going from cos back to sine. We're going to get rid of the fact that there's a k there, and the sign stays the same, so it doesn't change from positive to negative. So we just have the integral then from of cos is 1 over k sine kx plus a, always remembering plus c, okay, for antidifferentiation or indefinite integrals. So you can see that when you differentiate that again, that comes out, cancels with the k, that disappears, and you get what you started with over here. Okay, so that's for sine. And then similarly, for cosine, when we differentiated cosine, we ended up with negative k sine kx plus a. So going back the other way, to integrate sine, we have negative 1 on k of cos kx plus a plus c. Okay, and you can see if you differentiate that again, that comes out, cancels with this k here. We have the negative, and we end up with what we started back at the beginning. Okay, so they're really just a couple of formulas that you sort of need to remember them and just get quite fluent with using them. But if you remember how to differentiate, you can always work out how to go backwards the other way. So we'll jump straight into a number of examples. Okay, so the first one, just finding antiderivative. So remember, antiderivative means indefinite integral, which means don't forget plus c. Okay, you must remember plus c. So for this, let's do a up here. So we're going integral of sine 3x plus pi over 4 with respect to x. Don't be tempted to try and integrate pi. Okay, similarly, when you're going the other way, don't differentiate it. It does tend to trip students up a little bit because it looks like a symbol. It looks like it might be a variable. It's not a variable. You will know that it's 3.14159. Okay, so it's constant, so you can't integrate it, or at least in this case, and if you're going the other way, you certainly don't want to differentiate it. Okay, it'll just come out at 0. So what we need to do with this one, sorry, that's our constant, so that's our kx plus a kind of style, based on the formula we had on the previous slide. So in order to integrate that, we're going from sine, we want negative cos, and we want negative 1 over k, which is 1 over 3. So it's negative 1 over 3 cos, and then this doesn't change. 3x plus pi over 4. Okay, and don't forget plus c. And then for b, so integrating 1/4 sine 4x with respect to x. Okay, so again, it's going to be negative because we're going from sine to cos. We need the 1 over 4, so that's going to become 1 over 16, and that's cos of 4x plus c. Okay, so it's really like 1 or 2 mark questions. It's just a single step of working, just making sure that you get, if you're going from sine to cos, you've got your negatives, and that you are dividing by that k, whatever the derivative of this function in here is. Okay, so now we've got definite integrals. So we're not doing plus c, we're looking at over a given interval, as we've got here. So the first one, we're integrating from 0 to pi on 4, and note that it says exact values. Okay, so you need to be familiar with your exact values of all your trig ratios. So sine 2x dx. So the first thing is to get the integral there, which will be negative half cos 2x. And that's happening over 0 to pi on 4. So we'll have, starting with pi on 4, negative a half cos, and that would be pi on 2. Substituting in pi on 4 for x there. Take, use your brackets, negative a half cos, and that would just be 0. Okay, so now relying on our exact values, I know that cos of pi on 2 is 0, and I know that cos of 0 is 1. So that's going to be that negative becomes positive, plus half times 1, therefore my answer is a half. Okay, so that's the definite integral over that given interval there. And then for b, it'd be up here, So we're now going from 0 to pi on 2 of 2 cos x plus 1. Okay, so to integrate that, we get 2 sine x plus x between 0 and pi on 2. So starting with the top, the upper limit, pi on 2, that gives me 2 sine pi on 2 plus pi on 2. Take 2 sine, let's use brackets, 0 plus 0. Okay, so I know sine pi on 2 is 1. 2 times 1 plus pi on 2. Take, now sine of 0 is 0, so that's 2 times 0 plus 0, which all turns out to be 0. So you just end up with 2 plus pi on 2. And you can leave that just like that. You don't have to do anything else with it. Okay, and of course you can do this on your class pad as well. So we'll just quickly run through. Just make sure you're in radians. But let's just do the first example. So we had sine of 2x, oops, not times, sine 2x. Okay, so we want to go integrate definite from 0 to, and this will quite happily take pi on 4. Okay, and it gives you a half. And if you do this and you have it in standard, it'll actually give you this exact value as well. So again, your class pad is brilliant. The only problem being that a question like this would be in the non-calc section. So it's when you're studying, it's a really good idea to do these by hand and then use your class pad to check. Make sure you get the answer right. Okay, example 3 is a little bit more of a practical example. So now we're actually finding areas. We're not just doing definite integrals. For this one, it says the shaded region, so it's all going to be positive anyway. So we don't have to worry too much about signs or anything like that. We can just integrate over 0 to 2 pi. So we've got the integral from 0 to 2 pi of sine of x on 2. And that will give me negative 2 cos x on 2 between 0 and 2 pi. So we've got negative 2 cos of pi, because 2 pi on 2 is just pi. And then take, and now we've got negative 2 cos 0. Okay, so I know that cos of pi is negative 1. So we've got negative 2 times negative 1. And then we've got take negative 2 and cos of 0 is just 1 there. Okay, so when you sort out all those negatives, what you end up with is 4 units squared. Okay, and if it is asking for an area, do put units squared. You don't want to risk losing marks for not putting units. Now, last example, we've now got a positive area and a negative signed area, so we want to consider these separately. Positive, negative. Okay, so fairly straightforward, doing exactly the same thing. So we'll start with area 1, going from pi on 4 to 5 pi on 4. And we're integrating sine of theta minus pi on 4. And now my variable is theta, so I'm integrating with respect to theta. Okay, so that will give me negative cos theta minus pi on 4 from pi on 4 to 5 pi on 4. And if you are asked to do this without a calculator, then they will make these numbers quite nice. So they work out to nice exact values and not sort of nasty things that will trip you up. So we got negative cos, of course, 5 pi on 4 minus pi on 4 is just pi. So you do need to be good with your fractions as well. And then take negative cos, and this will be 0. So that will give me, that's negative cos of pi is negative 1. Take, and then cos of 0 is 1. So that becomes negative 1. So you can see how these are starting to get a little bit complicated, because that'll be 2 plus 2. Sorry, 1 plus 1 gives you 2. So that's for A1. But yeah, you can see how careful you need to be with your negatives, because if you miss one, then you're going to get into all sorts of trouble. A2 is now the same thing, but we're going from, so we've got, this is the integral here, so I'm not going to bother writing out the first bit. From here, and we're now going from 5 pi on 4 to 9 pi on 4. Okay, and what that'll give me is negative cos 2 pi, take negative cos pi, right, and that gives me negative 1, and then I've got take, and then negative, and then cos of pi is negative 1. So lots and lots of negatives, and of course what you end up with is negative 2, which we expect because this is negative. So the total area is going to be 2 from A1, and then we're going to say plus 2 from A2, taking the absolute value, and then it also turns out to be 4 units squared. But what you should be able to see is that if you did this on your class pad without considering the fact that this is positive and this is negative, you'd actually get an area of 0 because the areas are equal. One's positive, one's negative, they cancel each other out. So if you did that and you end up with an area of 0, that might start ringing alarm bells if you're trying to find exact areas under curves. Okay, so like I said, in this course we only consider the integration of sine and cosine, and these are the rules that you need to know. If you can differentiate them, you can work them out backwards. So don't need to stress too much about memorizing, but it is good practice to just recall in your mind that when you go from differentiating, if you can go back the other way, that'll just give you integration. Okay, remember plus c. Don't forget plus c. You're all going to do it. Everyone does it. Try not to do it in an exam. And then if you're asked for the area under the curve, remember that you've got to take into account the negative signed areas. So that little visual of checking where your function is positive and negative is really, really important. Like I always say, draw a diagram. It'll help.